Hey everybody, hope you guys are all doing well. Today what we're going to be doing is looking at 9.5 task, so go ahead and take that out. We're actually going to jump right into the task, so feel free to skip the warm-up and we'll go ahead and get started. So the first thing what we're going to be doing is we are going to be practicing the difference between identifying linear, exponential, and quadratics. So let's go ahead and look at this. So it says for each of the problem below, determine if the function is linear, exponential, or quadratic, and we're going to explain your reasoning. And we're going to find the missing representation, so whether it's table, graph, recursive equation, or explicit equation, so on and so forth. So we're going to find the missing one of those. Okay, so let's go ahead and jump right into this. It says a gym charges a base fee of $50 a month. So no matter what, you're paying 50 bucks. And then after that, you have to pay $5 additional to take a yoga class. And we need to figure out, determine if this is linear, exponential, or quadratic. So let's go ahead. To do this, let's go ahead first look at the graph. So this is the number of yoga classes. So if you don't like yoga classes, obviously you're not going to take any, and you're just going to spend $50 for the gym membership. So then what if you took 1, 2, 3, 4, 5? What you would do here is you would notice that you would add an additional $5. So it'd be $55, 60, 65, 70, 75, so on and so forth. So right here, you guys, you can tell it has a rate of change. It has a constant first difference of 5. So if we go back to A, it says determine if the function is linear. We know it's linear, and it's linear because the table has a constant first difference. Or another way you could have viewed it, or you might have saw has a constant rate of change. And just remember, for constant first difference, the definition, it says for consecutive x values, the difference between the y values is equivalent. That's what a constant first difference is. So if we were to graph this, we have our 0, and we just have 1, 2, 3, 4, 5, 6. And I'm going to do this little break point. If you guys don't know what that means we're just going to skip a bunch of points and jump right to 50, 55, 60, 70, 80. Okay, so when we go ahead now and graph this, remember it's number of yoga classes. You can't take half a yoga class, so this would actually be a discrete graph. So if I take 0 yoga classes, that's 50 bucks. 1 would be 55, 2 would be 60, 3 would be 65, 4 would be 70, and 5 would be 75. Okay, so you will make sure your graph is discrete. So what we want to do is create a recursive formula. So remember, recursive is just basically saying, how do I get to the next step? How do I get from where I'm at to the next one? And what we would do is we would take our previous value, and all we would do is add 5 to it. And for this instance, we would make sure we say f of 0 equals 50. That's our first starting spot. Okay, so really important, if I give you a list of recursive formulas, you know this is linear because you're just adding a constant. Now the explicit formula would just be f of x. You can use y. I'm not quite sure. Let me double check. I don't think they told us d or t or anything for time. So f of x is just $5 per yoga class plus the $50 to get in per month for the gym. So there you go. There's our first example. So the next one, what we're going to do is we are going to look at this graph, and what we're going to determine is if it is quadratic, linear, so on and so forth. And I know this is quadratic because all quadratic equations will form a parabola. So let's make sure we can see some key points here. We want to see where this parabola intersects an integer. So let me just go ahead and label a few of these points just so you guys can view them for our graph. Okay. All right, so let's go ahead and determine, so this is quadratic. And I know it's quadratic because graph is a parabola. Perfect. So what we want to do is multiple representations. So we kind of already labeled those points. That will help us out. I'll do it again really quickly just so we can see. Um, okay, I think I missed one right here. Perfect. Okay, so right here I have -3, -2, -1, 0, 1, 2, and +3. So then when I go ahead and label the corresponding values, when I plugged in -3, I had an answer of 4, -1. Let's see, when I had -1, I had -4, -5, -4, -1, and 4. So here's my table. You can see it has a table. So from this multiple representation, you can tell that this has symmetry, which exponential does not, which linear does not. So right here is what we call the vertex. It's where you'd find the axis of symmetry. And if you go one spot above or one spot below, they'll be the same number. If you go two spots above or two spots below, you'll have the same number, so on and so forth. So now what I want to do is come up with the recursive and the explicit formula. So let's go ahead and look at these one at a time. So if I were to look at my table, I have -3 to 3. So -3, -2, -1, 0, 1, 2, 3. And then I need the corresponding values, which were, I think it was 4. Yeah. Okay. 4, -1, -5. Nope, I already messed up. 4, 1. -4, -5, -4, -1, 4. Okay, so really quickly, in order to find the recursive formula, go ahead and shrink this just a little bit to make a little bit more room. Okay, move this here. What we want to do is be able to identify the first and second difference, okay? So in order to do that, let's go ahead and look at this table really quickly. Just add a few more lines here. All right, so let's go ahead now and jump and look into this. Just let me bring up one more thing really quickly. So let's go ahead and look at the first difference. So recursive, if you remember from 9.1, what we first need to do is we need to find, it looks like something like this. F of x is equal to the previous term plus a linear equation. So we need to figure out a y equals mx plus b. So in order to do that, we need to find the second difference. So let's go ahead and do that really quickly. So right here, this would be -1 minus 4. So -1 minus 4. That would give me -5. Here, -4 minus -1 is -3. -5 minus -4 is -1. -4 minus -5 is +1. And then -4, 4 minus -1, excuse me, 1 minus 4 is, I messed up. -1 minus 4 is +3, and then 4 minus -1 is 5. Okay, so now when I look at these, I'm going to do the constant second difference. Remember, in all quadratic equations, there has a constant second difference. So right here, if I do -3 minus 5, that would give me 2. -1 minus -3 is 2, so on and so forth, and you start to see these, okay? So let me go ahead then, and I know that this right here is my slope. So remember, the second difference in the linear equation that we're adding is my slope. So here. So now all I need to do is find a b value, and if you guys also remember, all you need to do is take one of these values for your y and one of these values for your x in order to find the b value for the constant sorry, just shrinking that really quickly. All you have to do is use one of those values to plug in to solve for b in your recursive formula. So we already know my m is 2, so I'm going to choose any of these points. And if you already notice it right here, you got a 0, -1. That might make it a little easier if you guys can see that pattern. You can already see the b value is -1. But let's pretend we didn't see that, and I'm just going to plug in 2, 3 here. So I'm going to plug in 2, 3 and have a slope of 2. So this would look like 3 is equal to 2 times 2 plus b. 3 equals 4 plus b. -1 equals b. And lo and behold, it's the same value. Therefore, you would have a final answer of f of x is equal to the previous term plus 2x minus 1. All right. Now the next thing is explicit. So this is kind of another review from 9.1. To find the explicit formula, you need to find it in standard form looking like this: ax squared plus bx plus c. And to find the a value is 1/2 the second difference. So my second difference is 2, so 1/2 of 2 is 1. So therefore, I know my a value is 1. So now what we're going to do is we're just going to plug in values on the normal table. We're not looking at the constant or the constant first or second difference right now. We're only looking at our original table value. So I'm going to clean up some more room. Just delete this part really quickly. Okay. Oops. And what we're going to do is just choose 2 of these values. So I'm going to start with near 0, -5 and plug that in, the point 0, -5 into this right here. So I already know my a value is 1, and I'm going to plug in 0 for x, so 0 to the second power plus b times 0 to the second power plus c is equal to my y value, which is -5. All right, so when I do this, this right here is 0, and I put a squared there. That was a mistake. B times 0 is just 0, plus c equals -5. And then right here I'd get c equals -5. Cool, so I have 2 of the 3 values. All right, so now I'm going to choose another one, and I'll just choose 1, -4. Choose easy numbers to plug in. So let's go ahead and look at when I plug in 1, -4. So I'm going to plug in 1, -4. So now I know my a value and my b value. So it would be 1 times 1 to the second power. My b value I don't know, so I'm going to plug that in right now. And then plus c, and I figured out my c was -5, and this is all going to equal -4. So then when I go ahead and solve, 1 times 1 times 1 is just 1, plus b plus -5 is equal to -4. So then when I continue solving this, I'm going to get -4 plus b is equal to -4. And when I solve for b by adding 4 on both sides, I get b equals 0. So when I plug in all my values, then I'm going to have 1x squared plus 0b minus 5 equals y. And all that simplifies to is x squared minus 5 equals y. So that is my explicit formula. Okay, so next let's go ahead and look at other representations if we have any. I think that's all we got there. Perfect. So right here now it says determine if this function is linear, exponential, or quadratic. And you can tell by the graph that it is going down. It's approaching 0, never really touches 0. And this is an exponential graph. And it's actually going down. So it's kind of like looking at a half-life of some material. And you know what, this one, so the way I always can tell is to see if it has a growth rate. So if I started at 8, then I went down to 4, then I go down to 2, then you go down to 1. If you were to divide the first one by the second one, 8 divided by 4 is 2, 4 divided by 2 is 2, 2 divided by 1 is 2. It has a constant growth factor. So let's go ahead then and we can look at these tables. So we started off at -3, -2, -1, 0, 1, 2. You can even throw in 3 there if you want. Now we just have 8, 4, 2, 1, 1/2, 1/4, etc. So then on the recursive formula, if you guys remember the recursive formula, all it is to get to your current term, all you need to do is take your previous term and you need to multiply it by the growth rate. And as we just figured out by looking at the table, you can see it a little better. When you look at your consecutive x values, you just do 8 divided by 4, which is 2, 4 divided by 2, which is 2, 2 divided by 1 is 2, etc. 1 divided by 1/2 is 2. So that's what you know what it is. So we're just going to multiply the previous term. And I made a little mistake there. Sorry about that. 8 divided by 4 is 2, but you have to flip it. It's 4 divided by 8 is 1/2. 2 divided by 4 is 1/2. 1 divided by 2 is 1/2, etc. And the reason why I know it's a half and not 2, first you always take the second one divided by the second one divided by the first one, and you can tell it's a fraction because it's going down, not going up. So sorry about that. So it would be times 1/2, not by 2. Now the explicit formula, if you guys remember, is to get to my exact term that I want, what you're going to do is you're going to take your initial, your starting value, and you're going to times it by the growth factor times your time, your x value. So right here, my initial is 1 because that's where I'm starting off at. So f of x is equal to 1 times, we talked about our growth rate, which was 1/2, a growth factor. We'll take that to the power of x. So this can simplify of f of x is equal to just 1/2 to the x power. Okay, and next one. This one is obviously a linear function. It has a constant rate of change. So it's linear. You can tell because the graph makes a straight line. So graph makes a straight line. And you can tell that it has a constant rate of change. Okay. So let's go ahead and look at this. So let's see, what am I starting off at? -6 and 1, 0. Okay. So we got 0, -1, -2, -3, -4, -5. And let's see, what would I start off? I went from 1, 2, 3, 4. Okay. So I went from 1, 2, 3, 4, 5, 6. So when I look at this, guys, first off, I want to figure out what my rate of change is. It just changed in y over change in x, and you can look at that on the graph really quickly, or you can do the formula. If you just started at any point, I went down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. So I have a slope of 1. And to figure out my b value, I can just look at this right here. So my b value is positive 1. So that means my equation, you could use y or f of x, is equal to -1x plus 1. So the recursive formula here is to start to get to your current term, or you just take the previous term, and we're going to subtract 1 to it. Okay, so right here, let's see. And you can just say f of 0 is also equal to 1. But that wasn't where I started at. Where did I start off at? F of -6. Is equal to 7. You can write that as well. Okay, so let's go ahead now and look at our final example. It says Brian does 5 push-ups on his first day at the gym, and each day he increases by 3 push-ups. So it's basically saying here's day 1, day 2, day 3. He started with 5. He added 3 to his previous one, so he did, let's see, he increased his number of push-ups by 3. So he started at 5. He's going to do an additional 8 to get to 13. He's going to add additional 11 and do, what would that be, 24, so on and so forth, okay? So let's go ahead and see what that would look like on our table. So one more time, remember he's adding an additional 3 push-ups. So he did 5 the first day. He's going to do an additional 8. Then he has done a total of 13. Then he's going to add an additional 11 to get to 24 total. He's going to add an additional, let's see, 14, so on and so forth. So determine if this function is linear, explain your reasoning. So I just want to show you how I got those values. And if you look at that, that is just basically the constant first difference on all of these. So you can continue to do this. This would be 17, this would be 20. That would be the constant first difference. Well, I know it's not linear because it doesn't have a constant first difference. But if I go ahead now and look at this next one, 11 minus 8 is 3. 14 minus 11 is 3. 17 minus 14 is 3. 20 minus 17 is 3. Since it has a constant second difference, you know that this is a quadratic. And it's quadratic because it has a constant second difference. All right, so now let's go ahead and graph this. So if I were to look on this, day 1 I would do 5 push-ups. Day 2 I would do 13. Day 3 would do 24. Day 4 I would do 38. Day 5 I would do 55. And day 6 I would do 75. And you can start to see that this is making a parabola. Now really quickly, you're not doing push-ups 24/7, so you're not, slowly doing a push-up, so this would not be a continuous graph. It would actually be a discrete graph because each day you're doing these numbers of push-ups. Okay? And it only wanted two of, let's see, yeah, it only wanted those two representations, so we don't need to go any further. But remember, you'd see if it has a constant second difference, all that fun stuff. So, if you have any questions, please feel free to email me or your teacher. Remember, the point of this lesson was to look at the 3 types of equations we looked at. We've looked at linear, exponential, and now quadratic, and we need to differentiate between them. So yeah, have fun, guys. See you later.